We are DECOR, and we are challenging the current acoustic ceiling market. DECOR is a circular, modular and space-defining acoustic ceiling system that not only improves the acoustic qualities of your workspace, but it just looks way better. By combining the best acoustic materials with pressed cellulose fibers from ECOR, we proved that we should make this ceiling. DECOR is not only beautiful, but it makes your space more fun. And we all know people like cool designs. DECOR lets you shape your workspace to your own desire. It gives you the option of choosing a different inner tile. For instance, the Arca tile, the Versa tile, or the Re tile. But you're probably asking yourself, how does it work? Well, DECOR mounts to any commonly used ceiling structure, but we also offer our own structure with additional acoustic performance. To this structure, a universal DECOR connector is mounted, to which the boxes are pressed in. Each box is assembled by first folding the inner box together with the desired tile. This inner box is then clicked into the outside box. It's as easy as that. DECOR is your circular, modular and space-defining acoustic ceiling solution, shaping the experience of the room. DECOR, design today, apply tomorrow.
Yeah, so we are going to start with just a quick summary how we actually got there. So this is one of our first a bit more worked out concepts. So in the end, the idea was to have this kind of resonating box that we could fold together, and we could just simply click on different tiles on it. And then we developed some sort of a 3D printed connector to go with it, but we had problems with the connector at this point. And also aesthetically, we didn't really like how it looked from below. Then the next. Okay. Then this was the next version of it. So suddenly we found a different solution on how to fix the tile to the actual box, and also a new type of collector that would really this time allow us to simply from below click in, and it would be rest in place.
Yeah, we had many different iterations of the connector. And on the left-hand side, you see one of the first iterations we had, which made it quite difficult to mount the tiles to the substructure. And in the end, we aimed for the most simplest solution, which is the connector we have on the right, which made it very simple to attach the connector to the substructure with just a screw. And you just slot the tiles into the connector in order to hang it. Yeah, so basically, how does it actually work, this acoustic noise reduction? We just go over some principles that we used in the boxes. So the boxes, they really use the principle of reflection and absorption. So the shape of the box makes it that the sound wants to be trapped inside and actually go from below the ceiling to also up the ceiling, and then reflect and yeah, basically loses energy. And the inside of the boxes, they are lined with a very absorbent material. So that makes that the energy is actually absorbed by this material. So the reverberation time is lowered a lot. So just, yeah, you've basically seen this one already, but this is the overview of the structure with our designed ECOR substructure. But it can also apply to any standard T profile. And then this connector, the final version, it also has holes that zip ties can go through, and you can basically connect it to any kind of structure. So yeah, you've ordered this.
Yeah, and then you make it. It's like an IKEA box. So actually in the steps you can see how it's made. So you fold the box and then the inner box, like we said in our commercial, slot it together, put inner and outer box together, make the structure, and boom, it's finished. You can click it and plug and play, right?
Yeah, here's an overview of our proposal for the CEMEC Center. Here during the day, people all busy working, and at night, Mr. Bucky Lab is playing around. But yeah, now we want to produce 10,000. What did we find, and maybe what potentially could we change? We now really use the building method of laser cutting, but we were also thinking that maybe there could be a version where it's actually punched out to save energy. And we're still using how can we optimize the pieces that we have on the sheet, so that you lose as little as possible.
And also the connectors. Now we laser 3D printed the connectors, but we actually want to use injection molding, so it goes faster and it's a simpler technique. And then we want to also we folded the tiles right now, but we want to press the different tiles. And about the fabric.
Yeah, so when we actually made it, we found out there are still some tolerances to take into consideration, and also we have this fabric material on the inside, and we should have taken a little bit more consideration into thinking about that, so you don't have to go in with a blade to do it yourself.
Yeah. So that's it.
So that's, I think, our optimizations for upscaling the production. For today, this is DECOR coming from Delft to you. Thank you for your attention.